here. Okay. So let's go for the getting started for the Hackfest 8. So the agenda. The agenda essentially covers first what are new SDN controllers, the introduction of control and management protocols and data models. This is probably the aspect where we can jump some sections if you think it's not important. An introduction to Container Lab. This is because we will be using, not for all, but for some of the challenges, Container Lab for running an emulated data plane. And then we will cover also the deployment of TeraFlowSDN and some basic operations like onboarding devices. Okay. Okay, let's go ahead. So what are new SDN controllers? Why do we need SDN controllers and what are the new SDN controllers? We name them as network automation frameworks. Why? It's because it's not only about controlling a network, a software-defined network. It's about also automating things. So network operators need automation. Let me put the pointer. They need automation. This automation needs, means softwareization, and networks are complex. So we need to handle multiple kinds of equipments, different domains, technologies, and so on. So we need a robust and flexible software that can cover a wide range of different cases. Also, we have many domain-specific needs that should be automated on the network. So then the TeraFlow SDN develops an open source cloud-native SDN controller enabling smart connectivity services for the future networks beyond 5G. This is our motto, let's say. It's our objective. How TeraFlow falls in the landscape, at least in the ecosystem that we consider. We consider TeraFlow as the software-defined network controller. We support a hierarchy. So that means we can have an end-to-end SDN controller that is able to manage underlying controllers. Then we can have TeraFlow running as an IP SDN controller, as an optical SDN controller. This is more or less classical. TeraFlow also supports other flavors like a QKD SDN controller. So we already have some components that can manage at a basic extent right now, but it's something that it's being extended and used by some people as QKD. On top of TeraFlow, we consider we can have open source Mano or open slice that essentially what they do is request to TeraFlow connectivity services between sites, between different workloads, whatever. And well, open slice and open source Mano can interact with Kubernetes, OpenStack, whatever, that at the end are the endpoints that we connect by means of the transport network. Then, who is who? The leadership. Right now, CTTC is acting as the leader of the leadership group, and we have Telefónica and Telenor as we are chairs, and we have Telefónica and Telenor as vice chairs. In the technical steering committee, we have. I think this slide it's the old one. My mistake. This should be Canit. Okay, well, my bad. Sorry. Then we have CTTC it's leading, and in the technical steering committee we have Telefónica, Ubitec, Canit, and Chalmers. And in the members and participants, we have many institutions. Right now, I will not go through all of them because it will take a lot. The list is always growing and changing. So here we need we have the list in the TeraFlow portal. So whenever you want to see who is part of the team, you can just go there. In terms of the release 6 that was released actually last week, honestly, this is the architecture. Explaining the architecture a bit, I will not go through all the modules because you see we have a large number of modules, but the core modules are the context. This is the database that currently stores the information about the network elements. This means, for instance, the topology, the services, the, well, all this information, configuration rules, the links, and so on. Then we have the SVI. SVI essentially, actually it's named as device. It's in the plans to rename to SVI, but for understanding, I think it's better to name it as SVI. Essentially, this is a pool of drivers that implement different protocols, data models, interfaces in order to manage underlying devices. Okay. The third important component is service. Service implements a set of service handlers, and each service handler is responsible for managing a different type of service. So we can have services, for instance, for layer 2 VPNs, layer 3 VPNs. We can have services for optical connectivity services, for layer 2 connections on top of P4, whatever. Path computation is another core component. This is the one that is devoted to, as name states, computing paths for service. So essentially, service delegates on the path computation whenever a new service needs to be computed. And we have NBI and WebUI. Okay, the NBI and WebUI essentially, respectively, they offer a pool of NBI connectors with different standardized data models, and the WebUI is a very simple and easy to use interface that tries to facilitate the life of network operators. On top of that, we have the network slice controller that is responsible for exposing an IETF slice data model that it can be consumed in order to provision slices. We will have a session on the network slice controller, so I will not spoil my colleague's presentation for tomorrow. Just mention that this is one of the core modules also. And for the rest of modules, you see, we are featuring different things here, optical controller. We have also the analytics, automation, telemetry, and policy. Essentially, these four blocks form the new monitoring framework in TeraFlow that we are pushing and evolving release after release. We have the components devoted to quantum key distribution. We have BGP speakers, virtual network topology managers, end-to-end orchestrators that enable this stacking of multiple layers of TeraFlow, components on security, well, many more. If you have special interest on some component, just let me know at some time, or and we can elaborate. But for now, I go ahead in the favor of time. So about new features introduced in Release 6, well, we are building the foundation for autonomous 6G transport. That means three main aspects or dimensions: the programmability, observability, and the security. So we are trying to support flexible automation and policy-driven control. We are trying to enhance the telemetry and real-time network visibility. And also, we are trying to provide quantum safe security mechanism and energy-aware slicing. As per the policy-driven automation for real-time network control, well, we are featuring policy-based KPI observation for adaptive intent-driven network management, and so on. We are also featuring a new plugin-based automation services that ideally what you can do is to plug some piece of code that implements the specific logic for implementing some particular kind of monitoring loops. Okay, so that way you can customize the monitoring and automation as you need. And also in terms of slicing, we are featuring energy-aware slicing for a more sustainable resource allocation. In terms of telemetry for real-time monitoring, we are featuring P4 in-band telemetry for deep network insights. We are also featuring a new set of GNMI OpenConfig collectors that enable telemetry streaming. We are also featuring SIMAP. SIMAP stands for Service and Infrastructure Maps. This is some novel standards. I say novel because they are still in very early versions of the drafts that enable to define multi-layer topology models and showcase on top of them how are the connections routed, which are the resources they are consuming. It is cross-layer, it's cross-service. So I have few slides on that. So the idea is, well, as I was mentioning, this is a data model from the IETF. And the idea is that this data model bridges the gap between network layers. So you can have, for instance, the different layers, physical, IP, optical, also service layers interconnected among them. So it's something that can enable also to connect external models like inventory, traffic engineering, service assurance. And with all this, we enable the network operator to navigate through the different layers. Okay, so the network operator can see how everything is interrelated and used. So, well, I will jump. Here we have a more nicer slide. So with SiteMap, we get a number of key benefits, including better network visibility, improved network management, increased automation, optimize resource allocation, service reliability, digital twin support, because SiteMap, as you might expect, can serve as an enabler for network digital twins and simulations, what-if scenarios, and so on. And then we provide enhanced flexibility, security and scalability, because we can expand different network domains, technologies, and also we can expand to very large networks. In terms of IP and optical network control, we are also supporting FlexGrid lightpath deployment, optical bandwidth expansions, coherent pluggable connectivity, integration between IP and optical with IP over WDM service management, orchestration, and so on. In terms of quantum safe networks, we are featuring new integrated tests that enable to validate that the QKD features are stable and keep working properly. Well, this is in view of preparing TeraFlow for the quantum safe network security and the future infrastructures for 6G. And well, here maybe I will go fast because I was presenting all this quickly. It's a bit of repetition. So this is more or less already saying it. Here maybe mention that we have support for Open ROADM also as optical controller. We have support also for the digital subcarrier multiplexing coherent pluggables. We have integration with OSM out of the box, both as an SBI for establishing site-to-site connectivity services, but also what we can do right now is that TeraFlow, for instance, requests to OSM the deployment of a virtual router wherever it is needed. So in that sense, we can act as NBI or SBI for OSM in different scenarios. Security, I more or less explained that. The missing point is that we also feature now a new programmable firewall agent that is based on RESTconf OpenConfig that you can use, for instance, to leverage peer-to-peer secure IP connections. So the idea is that it's an agent that you deploy in the server in two servers or two machines. Then we can also control intermediate firewalls, also by means of GNMI OpenConfig. And with this, we can set end-to-end, that means server to server, the ACL rules for the securing specific IP connections. And about the network slice controller, I will leave this for Javier tomorrow. And well, some enhancements in the web UI, the DevOps with additional tests and so on. This will be about TeraFlow new features. This is the list of NBIs and SBIs that we support in TeraFlowSDN. You have the list updated always here in the wiki. And this is the collaboration with the different open source groups and communities that, well, open source and standardization bodies, SDOs in general. So mainly it's open source man, OpenSlice, and OpenCapif right now, and then with a number of ISGs from Etsy. especially MEC, fixed 5G and ZSM, TS from IETF, CCAMP, ONF, now Linux Foundation with Transport API and before mainly, and some industry organizations like the Telecom Infra Project and OpenConfig. That will be more or less introduction on the TeraFlow and the new release. I jump now to control and management protocols and models. I don't know if there is any question, comment you want to raise now until this point.
Hi, Lluis. I'm
Yes.
Jimin. So, frankly speaking, I'm relatively new to SDN. I'm almost zero to TeraFlow. Okay.
No
So
problem.
I have
Welcome.
one question. I'm not sure whether it's a good position now for me to raise up such questions regarding the optical pluggable. I mean, I don't know what's the current support by TeraFlow. Let's say if I want to use the TeraFlow to make some configuration, I mean simple configuration like frequency or the power for one pluggable, let's say from one company, let's say Nokia or Altran, then we put this pluggable into some switch, let's say from Cisco or from Juniper. I mean, what's the current status for TeraFlow to support such application?
Yeah, this is a very nice and interesting question. It's related on the optical controller. I could try to reply, but I think, well, it's optical control and pluggables. I could try to reply, but I think maybe it's a good question you can raise tomorrow to Andrea after the lunch break, because he will be providing a tutorial on the optical controller, TeraFlow as optical controller, and he's the one that it's fighting day after day with pluggables, placing them here and there, data models, protocols for managing them. I don't know if you want, maybe we can postpone the question to tomorrow, and then you will get the question from the expert, let's say,
Okay,
of this.
sure. Sure. Yeah, great. Thank you very much.
You're welcome. We are here for
But
that.
maybe Luis, let me jump in. Maybe he
Yes.
doesn't need to wait for the expert. I mean, there's some documentation that is available on the different southbound interfaces that are programmed. This is I have just copied it in the chat.
Oh yes,
So feel free to go to browse the documentation. I mean, documentation is not perfect for TFS, but at least it has some it shows some things. I would recommend that if you cannot wait until tomorrow for the answer or for the presentation of Andrea, you will see that we have several videos on open the optical TeraFlowSDN controller. Let me check and I will copy and paste them in the chat.
Okay, great. Thank you very much.
Yes, mainly it is based on OpenConfig, OpenROLM, and NetConf, I will say, the control. But for all the details and the particular technologies and so on, Andrea will give you a better view. But indeed, I mean, you have this the SBI, and there you can check. More questions? If not, I go ahead with this introduction to control management protocols and data models. First of all, I want to ask if you are familiar with things like Yang, NetConf, OpenConfig, all these protocols, data models. If I say these words, do they sound to you, or they are completely new? It's just to know at which level I should go. If not, I go to the normal presentation and that's it. If you already know, you just ignore me.
I know, but I don't want to talk about for someone else who doesn't. So,
well, provided that you mean it's new to SDN, maybe it's good that I go slowly presenting
just
the different
at least,
things.
completely new as well on the chat. So definitely.
Yeah, okay. Let's go slowly then. Okay, so for a Yang language, essentially, Yang is a data modeling language. What does it mean? It's a language that is used to define how should the messages be formatted. Okay, so let's go for an example, because sometimes an example is better than 1,000 words. Imagine that we need to define topology. This is based on an example that was being prepared by Ricard, as you see. Thanks, Ricard, for that. And the idea is that here we represent, okay, if you want to model a topology, typically a topology is composed of, well, a topology. It's composed of a list of nodes and a list of links. So on the top, on the very top, we have a container that says, okay, I use this grouping, name it as topology, and then the topology grouping inside has a list of nodes, it has a list of links. Each node is identified by a node identifier, and the fields are defined in another group that is named as node, okay, that we have here. This node, for instance, as we said, it has an identifier. So this field that we have inside, it's the one that is used here as key. And then it has another list, indeed, that is the list of ports. Again, each port has an identifier and a list of fields. The fields of the port are here in this grouping. That is the list, the leaf port ID that is of type string. Okay, it's a very simple example, but just to illustrate. And then for the link, similarly, we have each link has a link identifier. Well, it's identified by a link identifier that it has that is defined here in the fields of the link in this grouping. And then besides the link identifier, it has 4 fields, which are the source node, target node, source port, and the target port. Each of these fields is, in this case, it's not a free text string. In this case, it's a leaf reference that points to a topology node ID, okay, for the source node. That means the value that I specify here needs to be one node that already exists in topology node ID. Okay, so it needs to be an existing node in this list. This is what this leaf ref path blah blah means. For the port, it's similar. Okay, it's a simplification. Then we can sophisticate these paths very much to add protections and ensure consistency. I don't want to go to such a level of detail because it might take a whole day to explain this thing, and it's not the objective. It's just for you to understand. And then there are many tutorials on Yang that you can check and follow. But this is the concept. So that way we can define a topology with the nodes and the links. Then, if we use, for instance, some tool like Pyang or something, we can expand or convert this Yang definition into something that is a bit more understandable in terms of structure, that is the tree. Okay, in this tree, you see that the module topology, it has a topology container that in turn, it has a node, it has a link, the node has an identifier, has a list of ports, and then each port has an identifier, blah, blah, okay? So what we were mentioning. And then also you can see here, for instance, that you can ask to Pyang bind. I don't have here the commands because I wanted to make it simple, but you can see here, for instance, an example of how to represent this topology. Okay, in this case, we have 2 routers, each router with 2 ports, and then the 2 routers are connected by means of a link. That's it. This is briefly on Yang. In terms of netconf protocol, it's a protocol that is used to configure network equipment. Okay, it can be used for many things because it's quite generic, but the typical use is for configuring network equipment. The good points of netconf protocol is that it's based on a transport protocol layer that you can use, for instance, SSH. Then on top, you define a number of remote procedure calls. These are the typical ones. So getting the configuration and state information, getting configuration only, edit configuration, copy configuration, delete configuration, log the data store of the device, unlock, close sessions. So you can do these basic operations, and based on these basic operations and messages encoded following young data models, what you can do is to inject configurations into the devices. Okay, so it's this is the de facto, or one of the de facto ways to configure network equipment nowadays. So then, other means. You also have, for instance, gRPC and protocol buffers framework. This is something that arose from Google. Okay, this comes from the Stubby RPC used in Google that they open sourced. And then with this interface definition language, because it essentially what it does is to define an interface for your applications, you can define things like, okay, imagine that I want to implement one server, okay, in C++, let's say, that I want my clients in different programming languages to consume. It's boring if I need to implement the same code for multiple clients, or maybe I have servers that are implemented in different programming languages, whatever, having to code the very same thing multiple times and sometimes failing. A way to do that is using gRPC and protocol buffers. So here, for instance, imagine I want to implement a search engine that offers a search method, okay? Then I can say, okay, my request will contain just a single string that is a query. My reply will be the result that contains title, URL, and maybe a page content snippet, okay? Just with this piece of code, the gRPC framework is able to compute or to generate the code for your gRPC server, a skeleton for sure. Then you need to implement the logic for the different methods. Also the stubs for the clients that then you can consume directly, and whenever your code instantiates this stub and connects to the server, you can directly issue a request formatted with this gRPC. Okay, so this is an alternative, for instance, to a netconf. And actually, what happened is that the GNMI protocol arose. GNMI is a gRPC network management interface that essentially it's a protocol buffers plus gRPC that implements a set of services for managing network equipment. Okay, so you have essentially four methods, which are the retrieve the capabilities of the device, get the configuration of the device, set the configuration of the device, or subscribe to telemetry streams. So here, for instance, you can issue a request for getting configuration. You define which is the prefix path. So for instance, a slash components slash whatever, and you will get the list of components that compose a network equipment in OpenConfig particularly. You can provide a specific paths if you want. So the prefix is just the first part, the common part, and then in path you can provide the specific elements, some settings on what do you want, if you want configuration, state, operational data, whatever, data types. I will don't enter into all the details, how it needs to be coded, and then you will get a response that contains the data. Okay. Later we will see examples of that. So right now I just give it at a glance because it's something that, again, it might take a lot of time to explain in deep detail.
Can I ask a question on that?
Please.
Quickly. So I know most of the time you would use whatever protocol is supported by the device, but if you had the choice between, let's say, GNMI and netconf, is there one that you would choose, like one that would be easier to use, or like what would be the big difference between the two, and which one would you choose if you had the choice?
In my opinion, GNMI. I will choose GNMI for one reason. I remember an article from Ricard from some years ago where he was comparing things like the performance, the size of the request and reply messages, and so on of the two choices, and GNMI was winning by orders of magnitude. And also another good point is that in GNMI you have this feature of the telemetry streams that in netconf it's absolutely not available. Well, you have similar things in netconf. There is support for some kind of how to say that, which is the word, rudimentary streaming, but it's not very efficient. Also, the problem is that it's with netconf, it's mainly based on XML messages. Typically, it's not very convenient. At least in my opinion, I prefer GNMI when possible.
Yeah. Okay, thank you.
Welcome. And then we jump to the OpenConfig, the data model now, because GNMI is also from OpenConfig, as you see here. But now jumping to the data model, the OpenConfig data model, it's the data model that was, it's for sure it's open. It was designed by multiple vendors trying to find an agreement on how to manage the network equipment in a generic and integrated way. So they try to provide abstractions for the main elements that you need to manage in majority of network equipment, and they end up with this design. Okay, so you can see here, for instance, that under the device you have the platform. Platform essentially contains things like the components of the device. So you can see here things like which are the ports of the device, which are the transponders, which are the CPUs, the fans, power supplies, the network processing unit chips, that means the ASICs essentially, whatever thing that is physical in the platform, well, even software, because you can get here also the software versions, the operating system, and so on, it's reported here. You can also, I mean, I will not go through all of them because it takes a lot of time. Now we just go to the key ones. Interfaces, for instance. So it enables to retrieve and manage interfaces, both physical, logical, virtual, whatever kind of interface. It also supports IP version 4, version 6, Ethernet, link aggregation groups, whatever you need. Network instances, it's also key because it enables to deploy what in Cisco is typically known as a virtual routing function. So it is represented as a network instance. I mean, I would say network instance, it's an abstraction. It's a level of abstraction that is higher than VRF, because as you see here, VRF is a kind of network instance that you can implement because it supports things like segment routing, multi-protocol level switching, VLANs, routing tables, static, dynamic, whatever you need. What else? Access control lists. If you want to manage, for instance, security in terms of which packets can come in or go out from a specific box. I mean, it's quite optical elements. So if you need to manage optical equipment like reconfigurable optical and drop multiplexers, amplifiers, wavelength routers, whatever, you have data models for that. So, well, in summary, it's something that is very complete. And here it's just an example of how it looks like. Okay, in this case, it's the data model for the interfaces. And you see here that we have a container of interfaces that has a list of interfaces indexed by name. And then each interface has its name. It has a block of configuration. This is something particular. Well, it's also seen in other data models, but OpenConfig, I will say, was the first one doing that they release in each resource that you manage, one block for configuration and one block for state. That means in configuration, I define what I want. And in state, I get what is already available in the resource. So if I want, for instance, to change I don't know, the MTU of a specific interface, I can check, okay, which is the current MTU in the interface. I check in state. Then I say, okay, I want to change. I send a message to change the MTU in configuration, and then I can keep polling state, and whenever or implement some telemetry stream that notifies me when the MTU has changed in the interface, in the state of the interface, and then whenever I get the MTU that I was configuring, I know that the MTU is now what I was expecting. And the same thing I can do with enabling, disabling interfaces, configuring whatever thing I might need. Okay. So well, this is just an example. For the interface, you can have also the sub-interfaces, again with config state. You can define also for the sub-interface the VLAN tags. So well, I add a lot of dots here because if you check the data model, it's honestly huge. There is a repository in GitHub that details each and every bit and piece, and it's huge. IP addresses for sure. So well, this is just to give you a quick overview of how it is. Questions until this point? It's more or less understandable. Are you following? Okay, I understand silence means everything is clear. Then the next section is on Container Lab. Here, what I will present is a tool that can be used to emulate networks. Okay, so the idea of Container Lab is that, okay, we have a lot of network operating systems from different vendors, but what if I want to play with them? What if I want to create a small topology in my laboratory for checking what happens if, or how to configure something, and I don't want to use a real equipment that might cost thousands of euros. What I can do is deploy a small lab in Container Lab, okay, and deploy this lab specifying the network operating systems that I want, provided for sure that the vendor or the organization that is releasing this network operating system releases it compatible with Container Lab, that's for sure. And then what you get is a CLI that enables you to orchestrate the different labs, okay? So it enables to start containers. You can it enables you to build the wiring between the different containers that run the network operating systems. You can manage the life cycle of the labs and so on. You can also perform traffic captures directly on the virtual wires. You can you have a lot of well, a number of different kinds of devices that are supported. Later, if you want, we can go to the web page and we take a quick look. And you have many examples. That's a very good point. You have examples for a lot of different things. So, and you have the quick start for sure, if one day you want to run it. But I think with what I will show you here, more or less the quick start, it's covered. So as I was mentioning, you can implement a wide range of different scenarios. You can deploy two Nokia SR Linux connected routers directly. Maybe you want an SR Linux connected to Arista CIOs through a couple of wires and then another wire to another SR Linux. Maybe I want to implement a spine leaf or a super spine and leaf architecture. Maybe I just want here a spine leaf with a border leaf that can lets me test the connectivity between different elements. I mean, sky is the limit with Container Lab. It's a tool that I like it a lot because it's very flexible. We will be playing.
Excuse
Yep,
me.
please.
Does this tool open source?
Yes, it's open source.
Okay.
You can download it for free and use it.
Okay, thanks.
Welcome. So in Container Lab, for instance, what we will do in this Hackfest, I will show you a small scenario that is running in Container Lab. It's already prepared in the virtual machine, so you can use them. It consists of a couple of routers that are directly connected between them, and each router is connected to a Linux client that we name as Data Center 1 and 2. Okay. data centers are pre-configured, are statically configured with a specific MAC address, specific IP address, and a specific route that enables us to reach from one to the other. Okay, but the connectivity between the routers is not configured. So they don't have IP addresses, they don't have routing tables, they don't have anything. So if you try to ping from one to the other, it fails simply because there is actually no connection. The green lines here that you see here, it's essentially the management network. So what we do is we connect all the equipment through this management network, but the management interfaces. That means there will be no traffic going through these interfaces directly because we will be using these IP ranges that are only in these interfaces. Okay, it's very simple scenario, but it's useful for playing with TeraFlow, especially with the IP layer. Then, how we define the scenario in Container Lab? Actually, it's strange. I think this slide deck has some problem because I was upgrading this. Let me check something. Just a second, because I think this slide deck it's the wrong one. Okay, give me just a second, because I think. Okay, let me see if that's weird. I want to show you the latest version that I was preparing. Let me see this one if it has it updated. Okay, I don't know what happened, but I was updating it in the morning and for some reason it was not refreshed. Okay, that's boring. Well, I will manage on online, and then when I upload the slides to you, it will be updated. That's strange. This happened twice times today to me. For some reason that I don't know. Actually, replace all the Hackfest 5 that you have here in these slides by Hackfest 8. Okay, and essentially the paths should be similar. I'm reusing material in this case, as you can see, and for some reason it was not working. But well, anyway, how we define the scenario in Container Lab? Essentially, we define a name, we define the management network that we want to use. Okay, this management network will have an IP range. This is essentially this range that we use for managing the equipment. And then we define the topology. In the topology, we define first a block that is named as kinds, and we define the kind of elements of nodes, in this case, that we want to deploy in our scenario. The first kind of node will be an Arista CIOS, which is a specific router, a virtual router from Arista that it's featuring netconf and GNMI with OpenConfig. It's very convenient for us. We are using the version 4.32.2f. This thing is right. And as Linux boxes, we are using this network multi-tool box that essentially implements a small Linux client with the basic networking tools like IP route, showing the linking configuration, and so on. Then we declare the nodes. We say, okay, router 1 is of kind Arista CIOS and should have this management IP address. Router 2 should have this one. Data center 1 is of kind Linux. It has this management IP address, and I want to configure all these. I want you to run these commands on boot of this node so that it gets automatically configured with the IP addresses, the default routes, and so on. Okay. And outside of the nodes, then we have the links with the list of endpoints. So I say, for instance, connect interface ETH2 of router 1 with interface ETH1 of router 2. Connect the interfaces ETH10 of router 1 and router 2 to the interfaces ETH1 of data center 1 and data center 2. So at the end, we are defining this scenario in brief. After that, we need to ensure that we have the image. Okay, in this slide, it's again wrong. This should be 32 to F, and here again 32 to F. So we do a Docker import of this command, and well, with this command, what we get is the image of the CEOs onboarded in Docker as an image. So we can check then Docker image, and you should see something like that. We get the CEOs, and well, given that we are grabbing with the multi-tool, you should get also the multi-tool. Okay, so the images are in place, and then you just do a CLab deploy.sh. Essentially, this runs a command for deploying the container lab scenario, and after a few seconds, maybe a couple of minutes, you get your scenario up and running. Okay, you get the list of the different devices with the images that are being used, the kind of devices, their status, management IP addresses, and so on. And then you can for sure inspect at any time the scenario and get the data, and you can activate this graph that essentially opens a web page that when you navigate, you get a graphical representation of your topology with the different interfaces and so on. You can also connect to the command line interface of the different elements. So if you run the CLab CLA R1 script, I will show it to you in a minute. Then you can connect an issue, for instance, in different commands like enable, show running configuration, whatever thing. And well, you can destroy the scenario also. Okay. Okay, this is the part of Container Lab. Maybe I will show you a bit of code to change a bit, because so much theory, maybe it's a bit boring. So in the Hackfest, for the Hackfest, I was preparing here a Hackfest 8 folder. This is the right one, the one that it's available for you. It's already in the virtual machines, so you will get them. And here you have the scenario, okay, the Hackfest 8, as you see, with all the settings. In addition, I'm providing here some startup configuration that just defines, if you check that I want to enable by default the GNMI and netconf if you want to use, everything is unconfigured, and then it fixes also the management IP address and default routes. Okay, so the important part here is this. It's ensuring that we enable GNMI and netconf in the scenario. The same for the other router, and well, the rest is more or less what I introduced. Interestingly, you can see that for the routers, the startup config that I'm providing is exactly in the nomenclature that is used by the device. Okay, so these are the commands that you type, like a classical, it's similar to the Cisco command line interface. For deploying, you see sudo container lab deploy, you specify the file that contains your scenario, you wait some minutes, and then you should see something like, let me show, because I was running this thing a bit in advance. It should be here. Okay. So here you deploy the scenario, and now this is the inspect. Sorry, because I was running it a couple of times this morning, and I don't want to waste a lot of time now executing again. Yeah, here, this is the command. So you deploy Hackfest 8, CLab deploy, blah, 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 and then you will get that, well, it will start composing the links between the elements, deploying the different boxes, running the configuration commands for you, and at the end you get something like this, the table reporting the details of the execution. Okay, so this is one of the parts, and here for sure I can show to you if I TFS controller, you can go to Hackfest 8 and Container Lab, for instance, CLI router 1, and here enable, and right now we are connected to the interface of router 1. You see that it is unconfigured, as we were mentioning. Okay. You can also, as I was mentioning, the same for data center 1. You can connect, and here it's classical Linux, so you can do IP link and you get the links. You can IP route, you get the different routes that are pre-configured. So the configuration was done automatically. And here, for instance, if I ping 192.68.2.10, okay, this one it's on this site. It is where it is. Oh, sorry, IP address. Let me run first. IP address. So you see that the IP address of this site is 192.68.1.10. On the other data center, it's 2.10. So right now I should not be able to ping if I ping 210 because there is no configuration in the intermediate routers. So I get destination host unreachable. Okay, so well, this is just the brief introduction on a container lab. I don't know up to here if you have any question, if it's more or less clear, everything. Okay, if there are no questions, I go ahead. If at any time you want to do a break or something because you think it's too much, just let us know and we can make a 5-minute break for sure. That's not a problem. In terms of TFS deployment, I'm jumping now to the TeraFlow. Well, this is just a brief introduction on how to deploy TeraFlow. So as I was mentioning, TeraFlow, it's TeraFlowSDN, it's based on microservices, it's cloud native, and we run it on top of Kubernetes based environment. Okay, in this case, the one that we are using is MicroK8s, which is from Canonical. And the good point of this is that in one command, you get a Kubernetes environment up and running. So it's very convenient. We have a huge documentation explaining how to deploy each bit and piece of configuring each bit and piece that is relevant to TFS. And for running the TeraFlow, the typical specifications that you might need in the server are to use a Linux-based distribution. Typically, we use Ubuntu. It was tested with 20, 22, and 24.4, the last LTSs. You typically need for virtual CPUs a minimum of 8 gigs of RAM. I recommend more if you are developing or if you want to do something like deploying network operating systems with 8 gigabytes of RAM, it might be a bit constrained for the network operating system because typically they might require easily 2 to couple of gigs of RAM per router. Okay, and then something like 16 gigs of storage, a bit more if you want to develop or run network operating systems on it. Okay, for simplicity, we are providing a virtual machine that is already installed with MicroK8s and everything. It's provided by Etsy. And to deploy TeraFlow, well, the first point is configure MicroK8s. As it's in the documentation, you will see it's a couple of commands. It's not difficult. Then we check that MicroK8s is up and running. If not, you can start it using the MicroK8s start command. Then, well, we check that after starting, we check that everything gets ready and the different pods in Kubernetes gets stabilized.
Sorry,
Yes.
Lluis. Just to interrupt you. So I have one question related to this. So to the deploy TeraFlowSDN, is it possible to deploy simply on, let's say, on my Windows laptop with WSL installed?
Yes, provided that in WSL you have Docker and some form of Kubernetes, it should work, yes.
I just to be sure, because Yesterday I tried to play with to install the when I installed the macro at K8S, it seems installed, but if I check the vet ready or not, this show something errors. And yeah, just to double check with you, I mean, is anyone already done this way or not? I mean, with the WSL.
Yeah. Typically, we deploy it. Well, honestly, I'm not very. How to say that? I don't like that much WSL. Because I was trying WSL in the past, and from time to time, in some cases, I got limitations, strange behaviors, and so on.
Yeah, that's true.
Honestly, I don't like to work with Linux-based things. I think it's much better a VirtualBox, for instance, a based virtual machine, and you get a full Linux properly flavored, because as I said in the past, and especially when you have to run things that might play in particular ways with the network and so on, with WSL that at the end depends on the Windows kernel and so on, expect strange behaviors. In theory, it should work, but to me, it will be normal to see strange behaviors, honestly speaking.
Okay, yeah, it's better not use WSL, I would say. Okay,
for me,
thank you.
Yeah, no, it's just my personal experience. In my case, the times I was using WSL, I at one time or the other, I finally decided, okay, let's skip WSL and go for the VirtualBox, because otherwise I was experiencing problems. Or maybe
Yeah,
it's just that you get a policy from your company that prevents WSL to do something. So then it's it's out of your control. At least with a VirtualBox box, you just have full control of what's inside.
Correct. I think your experience is the experience for most people. Okay, thank you.
You're welcome. Okay, then going ahead with the deployment. Well, for the deployment guide, you have the full documentation here. It's a bit long, and if you check, there are many flags that you can play with. Essentially, these flags are in now 5, because we are migrating these NATs, and we have NATs and Kubernetes and Kafka in parallel. The plan is to deprecate NATs and go for Kafka, because with NATs we had problems in the past. One block is for the TeraFlow itself. Another block is for Cockroach, which is the relational database. It's a distributed relational database that we use for TeraFlowSDN. NATS, now Kafka, it's the message broker for exchanging asynchronous messages, and QuestDB, it's also in process of being deprecated in favor for Prometheus and Mimir. It's the time series database. Okay, so these two ones are in process of upgrading or replacing. Expect that this thing might change in the future. Then we will not be changing here the default settings for Cockroach, NATS, and QuestDB in this case. But for TeraFlow, interesting fields. The pointer to the registry where you have the images that for the different components. This is where they will be stored while building. The script by default tries to build them. If you want to skip the build, there is a flag that you set to yes, and that it will not build them and will use the ones that you pre-built. Okay, in our case, we will keep this thing empty and we will keep this to the local host. This is essentially a Docker registry that we run inside the microcaches. Okay. Then we specify the list of TeraFlow components we want to deploy. You see here, it's just the core services, in this case, the context, the database, the device, which is the SBI, path computation, the service, the NBI, and the web UI. And then we specify which tag we want to use for the images that will be built. In this case, we use dep, and the namespace in Kubernetes where we want to deploy TeraFlow. TFS in this case, These are some extra settings because we can expose TeraFlow through an Nginx ingress controller in Kubernetes. We will do that in the default way. And then for in case we want to use monitoring, we can define the Grafana password for automatic configuration. This is something that we are upgrading because we are upgrading all the monitoring framework, and we will probably not use this thing in this Hackfest, I guess, because it's quite initial. Then, funny, this slide, I removed it. So I don't know what's happening here. Well, anyway, this is more or less repeated of what I was mentioning. Okay, whenever you deploy TeraFlow, you will see the progress during the deployment. It should be something similar to this. So you see first the deployment of the cockroach database, the Nats/Kafka, the QuestDB. Then it will delete the previous TeraFlow namespace if it exists. So that way we start from new. It will create some secrets with keys, passwords, IP addresses, and so on for the different dependencies. And then it will start deploying the different components. For each component, you should see that it builds the Docker image, it pushes the image to the Docker registry, and then it tweaks the manifest, the Kubernetes manifest files, deploys the component in Kubernetes, and then it collects some environment variables that are convenient for developing. This will happen for each component. At the end, it will configure the ingress controller, the HTTP ingress controller for TeraFlow. That way we will be able to connect through the web UI to TeraFlow. And then it waits for the different components to get ready. Okay, whenever all of them are ready, if you are deploying some think about monitoring and so on, you will see that it's trying to configure the web user interfaces, the data stores for the monitoring dashboards, and so on. In this case, in particular, we are not deploying this, so you should not see this. And then it does a bit of cleanup. And finally, it shows a summary of the deployment with the different elements that were deployed. You can always report it again with this ./deploy.sh. This is something that I can show because here it's already deployed. So I go to TFS./deploy show. So right now it's deployed, and you can see here the core components that are deployed. I was deploying them like 3 hours ago in this virtual machine, the different services that are deployed. So this is the workload, this is the service that is in front of the workload, and then all these services and workloads are exposed through the ingress. Okay, so that way, if we go to the TeraFlow web user interface that I had it here open, we can see that it was onboarded. So, well, it's open, you can navigate through the different tabs, and in this case I was onboarding the scenario that I was showing in Container Lab. Okay, so this is right now connected to Container Lab, and I can see here, for instance, the different elements. You can see here, for instance, the management IP addresses of the elements that we have in the data plane with all the settings that TeraFlow discovered from the devices. Then going back to the slides. Well, this is about onboarding the devices. So in this point, well, it's just describing briefly how do we manage, again, this needs to be updated to Hackfest 8. So how do we manage the onboarding of scenarios in TeraFlow? We define JSON files that we typically name as descriptors of the scenario, and these descriptors contain essentially well, 3 types of elements for the topologies. The context/topology. This is transport API nomenclature. So we have a big context that contains everything, and this context can have a number of topologies. And then you define the devices that are in the topology and the links. that connect the devices. Okay, so going into the detail, for instance, this is the format of the JSON message for onboarding the topology. This is the receipt. You always copy paste this and just change the values that are in red. Okay. For declaring the devices, this is the syntax. In this case, it's for an emulated device, a pure emulated device that only resides inside TeraFlow, like emulated data center. In TeraFlow, we are not managing a data center, but we need to have the placeholder because if I want, for instance, to compose a topology like this one, where I want to specify that this interface is connected to the data center, and I can check here the links, I need to have the data center because otherwise I'm missing some information. So here, what we do is precisely this. We declare the data center in this case. We specify that the driver is this undefined. This is the one that we typically use for these placeholders that we don't really configure. They behave like a device in terms of TeraFlow, but there is nothing outside TeraFlow. Okay, so what we need to do for the simulated devices is to declare also which are the endpoints or the ports that that this box has. If we go for a specific router, for instance, here we can define that we want to use GNMI OpenConfig to configure router 1. We specify this is a packet router, okay? And we specify which is the management address and port, the credentials, and then the driver might have additional features. In this case, we are disabling the TLS encryption, okay? For the links, it's aligned. We have the receipt for a link. We essentially define the name. This is a free text that TeraFlow will automatically convert into a UUID if it's not a UUID. If it's a UUID, it will be kept. Okay, so here I can show it to you. Where it is. I have it here. So for instance, if I go to the links, you will see that the links have a name and a UUID. This UUID is computed from by TeraFlow from the name automatically. So that way, provided that you have different names, you will get different UUIDs. Okay, and something similar happens with the devices and their name. So for each link, we define the endpoints. So I connect router 1 interface ETH2 with router 2 interface ETH1. That's it. And TeraFlow, if you provide this as human readable text, TeraFlow will translate into UUIDs for you for facility. You onboard through this field this descriptor, the topology, submit, and then you select from this drop-down list the context admin topology admin, you press submit here, and in few seconds you should get the topology as we have here in the other slide that I was showing. Well, I was showing it to you. About the navigation, I will skip this. You will see that to navigate to the details of the elements, you have this A-shaped icon, and then you will get the details page. Okay, yeah, I will explain this in a moment. Let me go back here. This is what I mentioned. So you have this A-shape icon. If you go here, you get the details, and the same on the link. If you click here, you get the details. Okay. In case you want to check the logs of the devices or more than devices, the components, you can always use this show logs whatever command. This is something that I can show. This is very useful because sometimes, as this is a prototype, TeraFlow is a prototype, it's under development, sometimes it fails. So if you do /scripts/show logs and let's say device, you get the log of device. Okay, so in this case, it's in the log level, it's hike, it's info, so it's not showing the debug information. But if you change some settings, in particular, I can show it in the VS Code quickly. So if you, in the manifest for the components, we have here where it is, the device service. You see here that when we deploy, we specify log level information. If you change this to debug, okay, and you redeploy TeraFlow, what you will get is that the next time you execute things in TeraFlow, in the log you will get also the device log with all the detail. Sometimes it's overwhelming. It might be huge, but well, for debugging, you need to locate which is the specific part of the log that it's convenient to you, and then well, perform the classical debugging. This is just
I have a question on that.
Yes.
So, excuse me, like, how about the space? Like, if this logs is already saved into, I guess the device. So, do we already have some, storage issues, or like, could you also, the second part of migration is like, could you also have like a live logs? To be shown during like a process.
Yeah, right now it's not implemented. I know from Grafana Labs there are solutions. I don't remember the name. It's the Tempo. No, it's no Loki, I think. It's the tool, if I remember well. I don't remember exactly. But I remember from Grafana you have the logs.
Actually using Docker Compose, and with that I can also have like live logs and so on.
Well, if you want live logs here, you can have it, but for that I can show /scripts, maybe with a web UI, show logs, web UI. The script is very simple. So here it's just a kube control, blah, blah, blah. Okay, what you can do is do this and you add the follow. Oops. Forgot to add here the TFS, sorry. You add the follow and then you get the real-time logs. So here, if I now go to the, if I go here to the interface, you see that the log it's updating in real time. So it's possible, it's doable.
Oh, sure. Great, thank you.
Yeah, and it's true that right now we rely on the logging implementation of Kubernetes. There is no implementation right now in terms of log rotation or something. It is true that sometimes if you leave TeraFlow running for very, very long time, the logs can become huge. But if it's a development environment, given that you are deploying, redeploying, destroying, and so on, every time you redeploy, the log just gets dropped. So it's not happening typically in development. But it's true. For production, it's something to fix. Okay. Then next part is on layer 3 VPNs. Before proceeding, it's I guess everything is clear because more or less you keep raising the questions as they arise. Any comment, question you want to raise besides those that were already risen up to now before I jump to the layer 3 VPN part?
I just have a quick question. When you define the links and the device, do you have to do that for every new topology? Like whenever you start with a new topology, you define that within the controller, or you can sort of get that from, for example, we were talking about the container lab or something.
Right now, I will say yes and no. Let me explain. Yes, in the sense that TeraFlow has a BGP speaker component that if you connect to one of the routers and your routers have BGP-LS capacity and it's properly configured, then TeraFlow can discover the rest of the topology from that router. This is something that it's true, and some colleagues from Telefónica in the group of Juan Carlos, well, he was connected some time ago. It's the group of Oscar González de Dios, maybe you know him. They released this component for the BGPLS speaker, and then you can discover the topology. Actually, I can provide you, I guess it was Hackfest number 4 that was devoted to this, and there you can see some examples and demonstrations of this component. But if you don't have BGPLS in the devices, or they are not BGPLS capable, then it's true that you need to rely on manual configuration. We don't have a translation tool that converts right now from these container lab scenarios that I was showing from this to the other. Actually, it's something that can be done. It's not. It might be convenient because it's not that easy. We have all the information here.
But then if you connect to a real devices, do you have to use the same UUID as the devices have, or the one from TFS is the new UUID?
Which UUID you mean from the devices? This one?
Like if you use, for example, well, if you use TAPI, for example, and you retrieve the topology, it gives you some UUIDs of all the devices that you have underneath. I mean, I took for the optical part at least. So is it the same UUID that you need to define or expose to TFS?
You can use them if you want. Yes, sure.
Okay.
Yes. I mean, TeraFlow it's not stringent in that sense. So if you provide a UUID, provided that is unique and doesn't conflict with any other UUID in TeraFlow, TeraFlow will be fine. It will not complain. I see, Manel,
Okay, but
you have a question. Yeah.
Yes,
Yes, please. No, Julie.
No, go,
Oh.
Julie.
It could be different then. It doesn't have to be the same, the UUID.
Yeah, it's not mandatory, but if for convenience you want to use the same, it's doable. Yes.
Yeah, okay, I see.
Yeah, Manel, please.
Yeah, I wanted just to add a question on top of the one of Julie, is related to the dynamic updates of the topology. So the topology in this case, it is static. And what about, I mean, how you consider if there is some changes in the topology, like we will have some new nodes or something like that. In another way, how you are reflecting this in real time?
Actually, in real time, you can do two things. If you rely on the BGP-LS solution, whenever the routers discover, well, the underlying routers where your BGP-LS speaker is connected to receive information from a new device, new links, and so on, TeraFlow can retrieve this, the BGP-LS speaker retrieves this information and can update the topology on board the devices and so on. If you don't have this BGP-LS support, you can rely on simply, let me go back to the slide, you can simply repeat where it is, this process. So this is not restricted to one single file. I mean, typically there is people that has maybe one file for the devices, another for the links. Maybe you have half of the topology in one file and half of the topology in another. So it's something incremental. So you can just onboard the additional part of your topology later on.
Okay, see, so it's like a link failure or something like that, so we will add it manually.
Yeah, the part of the link failure detection is something that is still not implemented. So yeah, indeed there are some parts that are still they need some rework.
I was just a bit curious. Okay,
Sure.
thank you so much.
Very welcome question. Okay, more comments before we jump to the layer 3 VPN? If not, then I go for the layer 3 VPN. Maybe you already know about layer 3 VPNs, so I will provide a very brief introduction. So the idea of the layer 3 VPNs is that, well, It enables multiple customers or multiple premises to be securely connected by means of remote networks. Okay, so the idea is that we can have a network operator that provides a backbone network, and then on top, that's backbone network supporting for sure IP, blah, blah, blah. And then on top, we can implement these layer 3 VPNs. It can use different technologies, so that, for instance, MPLS, bill tags, or maybe other technologies for routing and tunneling, whatever. It employs virtual routing function instances in the different devices for implementing routing tables for each of the customers. So that way, the routing tables of the inside the VPN are different from those on the network operator topology. And well, it provides privacy and security without the need for encryption, actually, because the traffic is isolated at the level of routing. For sure, assuming that all the routing is properly done and there are no leakages in routes and these kind of things. I mean, security aspects are always a concern. How it works. The idea is that the service provider edge routers are connected to the customer equipment, okay, which are essentially the routers or for instance, data center gateways that you might have. And then the CR routers are advertised via dynamic routing protocols, just multi-protocol border gateway protocol, and so on. And then, the traffic and the data flows can be encapsulated through MPLS, bill tags, and so on. And if you want, for sure, on top of that, you can add encryptions or whatever thing is needed. Use cases. Well, it's obvious. If you want to interconnect, for instance, different premises of an enterprise that are geographically distributed, if you want to secure connectivity between multiple branches, if you want to implement some integration of hybrid or multi-cloud environments, whatever thing that involves connecting multiple premises, it's in scope. With a single example, a single picture. Imagine that you have, as I was mentioning, a customer that has a couple of premises in IETF layer 3 VPN nomenclature. It's named as sites, okay? And you have a network provider's backbone, a network operator's backbone network. You can, the customer equipment is the one that is on premises for the customers, and the peer routers are the edge routers in the backbone network. Okay, inside these peer routers for that customer, the network operator will provision the virtual routing functions. You can have other use cases, for instance, with other virtual routing functions in the routers, so that way you can have two customers traversing the same segment of the network, but their traffic is isolated from one to the other, and whatever you want. The data model also supports high availability scenarios with primary backup connections through alternative and disjoint paths and so on. So it's very complete, even traversing backbone networks from different operators. But well, this is just a bit of theory. Here, the scenario that we were showcasing, the one that I was showing to you, it's very simple. Here you can assume that we have a couple of data centers that are statically configured to keep things simple. And then we have the network operators network, let's say, that is managed by TeraFlow with, and we will manage it with static routes for the sake of facilitating. I mean, at the end here, it's just to provide you a simple scenario to start. I don't want to complicate things very much. Going a bit into the detail with the layer 3 service delivery data model, it's the RFC 8299. Well, you have here in the link again Hackfest 8. you have the descriptor for onboarding this in TeraFlow, and this is how it looks like. So we have the layer 3 VPN service. Initially, we declare the VPN. We provide a name for that VPN, and then we define which are the sites that we want to connect. In this case, one site is data center 1, the other site is data center 2. We specify here that are provider managed, these sites. So that means the provider, well, actually here in this case, probably if you set customer managed, it should also work in this very simple scenario. Here, essentially, you can define if the site in the data, I mean, the customer equipment is managed by the provider or by the customer. You specify the locations for the different sites and the specific device identifiers that represent the sites. In this case, for us, it's the data centers 1 and 2. Then we need to define the site network accesses. We will see it in a moment. So for the site network accesses, in this case for data center 1, we define which is the interface, the access ID, which is the interface on data center 1 that we want to use. This is the one that is connected to the provider equipment router. We reference here the device where this access ID belongs to, the VPN it belongs to, and then we provide here the IP addresses and the prefix lengths. Okay, so essentially, as I was mentioning before, dot 1 is for data center 1, dot 2 is for data center 2, and the host ID 1 is the provider equipment. The host ID 10 is the data center data center gateway, or the DC1. For the service, well, you can define here things like maximum transfer units, input-output bandwidths, many things. Not all of them are properly, they are processed by TeraFlow, but the current driver it's not enforcing this in the underlying connectivity service. This is pending work, honestly. So if you want to work on that, that could be a nice feature to enforce, for instance, the bandwidth in the underlying services that are configured and deployed through a GNMI OpenConfig. For the other side, it's essentially the same. So I will not repeat. It's cloning the same and so on. Then, if you want to onboard this, we can run this this command. So let's try and let's see if it works properly. So I will go to the, let me paste. Okay. So we have here, you see, the IETF layer 3 VPN service. If we cut IETF, you see it essentially the file that I was mentioning with all the details. Now, let me, oops, not this. It's over here. Okay, let's try to execute this and see if it works. Oh, boring. Again. Okay. If it works, typically it reports this empty reply. So now we go here, devices. We see here that additional configuration rules were created for the different routers. So if we go here, we see that TeraFlow was computing, not this one, where it is, here. We see that TeraFlow was configuring the interfaces on ETH10, which is the one that faces to the data center, and also the IP addresses in the internal segment between the two routers. Okay, and the same for the other device. So if we go to the router 2, we should see the same. So it's another IP address in the same range, and then the .2 is towards the data center. Now, if we run the container lab, CLI, data center 1, we connect again. This is the one that previously was not working. So now if I run the ping 2.10 to the other data center, okay, I get the ping. So right now, connectivity is established between the two data centers. If I go now here and say, well, and I can show in the service, a new service, layer 3 VPN, was created, connecting the two data centers. It's active. You can see here all the details for the different settings, the IP addresses that were used, which is the path, and so on, and the parameters that were discovered. If I say now, okay, I want to delete the service, yes. It will take few seconds. Now the service has gone. If I go here to device, you will see that configuration rules were gone away. And here, ping is not working anymore because we have cut the connection. And well, in a couple of seconds, we should start getting things like a destination host unreachable because we have destroyed the connectivity. Okay, so this is just to showcase a bit how it works. So going back to presentation and let's finish it. Well, this is more or less what I was showing in real time. So I will skip. Well, you can retrieve identifiers and destroy the connection. I was doing it through the web UI, but it's the same. And well, I hadn't done that. I show it here that you can see the IP addresses, the routes that were configured in the routers. Okay, and if you want to play, you can always use tools like GNMIC, which is essentially a GNMI client tool that you can use, for instance, to connect to the devices. So in this case, if you are curious, we can run this command, copy, and if I, oops, not here, if I paste it here, it should take, no, mistake. I told you, Hackfest 8. So if I run it, you see, I can retrieve from the devices, the routers in this case, the different interfaces with their configuration. Okay, so I see here ETH2. Here, for instance, you have the interface for the management. And if you can see, for instance, that you can also get the state with the packets in, packets out, and so on. This is telemetry essentially, well, and so on, for all the interfaces of the router. Let me go back to the presentation, not okay. And well, this is the test that we already executed. So that's more or less the presentation. If you like it and you want to contribute, well, we have Manel here from Etsy, so she can explain more better than me how to manage, how to be part of the, well, you actually are part of the community, all the attendees, if I'm not wrong, because it's mainly ADBA, CTTC, and Telefonica, and I don't know if there is somebody else from other institutions.
No, all of them, they are participants or member of Etsy, so and TeraFlowSDN.
Okay, so that's good. That's good. And well, then I can skip all these details because you already know. If you want to follow, you know you have the links, and well, that's it on this tutorial. At the end, it was almost 2 hours. Not bad. Questions up to here? I hope it was not too much.
No, that was clear. Thanks.
Thank you very much. So then this is it on